Hello everybody, welcome back to our 2-Bit Circus Foundation live stream. I am Michael. Sorry, I'm just making sure everything was ready to go here. And we are back here with another wonderful project for us today after not making a video in 2 weeks. So I hope you all had a wonderful Thanksgiving. But we are back here. Wonderful project we have going for you today. We have the 2-Bit Circus Foundation self-watering terrarium kit. So this is actually a pretty cool kit. From what I remember of the project, we're making a terrarium where we are going to grow seeds and see those seeds come to life as a plant. It is not a build project in the sense of some of the other projects that we've done where you've had to put parts together and make something function. Rather, this is more in the realm of science when we talk about doing a STEAM project. So we are going to set it up as a science experiment. And obviously, you're not going to see the entire thing occur today, right? The seeds aren't going to magically pop to life within the short period of time we have here today. But we will show you how to set up the kit based on the components that we have here in the bag for you to set up a proper science experiment. Now, if you're a classroom teacher, you're going to want to go through the scientific method with your students and have them collect data, observations, and things like that throughout. And we'll talk a little bit more about that later. But just to give you an overview of where you can take this project, right? As always, we have a QR code on the front here that you can scan with a phone, any mobile device. You guys know how that works. And it's going to pop up to our lesson plans and future videos that we're doing right now, right? So in the future, you'll scan this and you will see me speaking to you about this kit, right? So it'll be kind of like a flashback there for you. All right, well, I'm done wasting time in the beginning here. Let's go ahead and I always want to just rip these things open, right? But let's make sure that we're kind of neat in case we need to store the contents in later. But I do want to be like a kid on Christmas time and just rip it open and see what's all inside here for us. All right. So first thing I see a couple of strips of paper here. And maybe they're sticky. I don't know. I can't get my little nail in. Oh, they are. These are little sticky papers, like tape on the other side. Cool. I think I know what those are for. We have a bunch of these repurposed sample cups here. Pretty neat, pretty neat. Oh, I think we have more sample cups in there. Awesome. So how many sample cups do we have? We'll do it like this. We have 5 sample cups. Empty, and then we have 2 sample cups filled with what looks like potting soil. All right. Then we have this cardboard tube here, just the tube. I hope you can see me through there. I can see you guys. And a top, like a cone top, cool, to go over it. We have beads here, some sort of beads. All right. And we have another cone, 2 more tapes, and seeds. These are pretty cool here. This is seeds. These are seeds. Seeds. And I believe they're grass seeds. Okay. So put our plastic to the side. Again, you can store the contents in that later. Now the idea here for this activity that you're going to do with kids is for them to understand how plants grow and what they need to survive, right? Like their basic needs. And so their basic needs are a couple things. They need nutrients, and I'm giving this away, right? So you won't necessarily want to show this video to the students. But they need nutrients from the soil, water, and sunlight. Those are the 3 things that plants need to grow, right? but you're going to do an experiment with students where they're going to produce or create the environment for the seeds and give them each a treatment to see what is exactly needed for them to grow, okay? So you're going to prep the containers first. That's step one, is to prep the containers, all right? And so you want to prep the containers all the same way. So we're going to open them all up. Open, open, open. 4 containers. I think I only need 4. Maybe we'll come back to that. Make sure that I only need 4. You're going to have to set up an environment for the seeds to be planted in. That's what we're doing by when we say setting up the container. Okay? So the first thing that you need to use from our kit are these plastic beads. Alright? And you kind of want to be systematic with them, right? When you're doing a science experiment, you're going to want to measure this stuff out in some way. You could have a numerical amount or a quantitative amount, qualitative as well. What I'm going to do is I'm just going to use this as a measuring cup, right? The top here, to see how much beads I am putting in each container. And let's just hope we have enough to do that, but that's what I'm going to do. And it would help if you don't drop them after your measurement. Okay? So maybe I should be careful on the next one, pouring them in there. All right. Let me grab the last couple ones there. And what you're doing here with these beads is you're creating a drainage layer for your plant, right? So the soil doesn't get too damp in there. All right. Just because they're sealed containers, right? So I have a little drainage layer, which is 1 top full of these little beads. Do the same thing to the next one. Again, you could have your students, if you're in a classroom and you have access to beakers and things like that, they can use those sort of measuring tools. But this is a good way in the kit to use a device as a measuring, right? You can make up any units you want, keep those units consistent. So I have 1 capful, base sample capful here. Cool. A little bit more careful with that one. Again, do the next one. 1 capful again. All right. Shake that around, make sure I have about 1 capful there. Awesome. Still dropping some, so I'll pick those up. Alright. 1 or 2 of these aren't going to make a difference, and really the drainage layer shouldn't matter too much, so long as you have a drainage layer. But it is a good way to get your students to start using measurement, right? And thinking about scientific experiments and how things need to always be measured. All right. And then we have 1 more to go here. Measure my 4th container out here. All right, again, a little bit messy, doesn't matter too much here, right? This measurement isn't too important for the experiment, but just get a hang of doing measurements. Awesome. Great, so I have 4 containers here. Now I'm going to use the dirt now, and the dirt is actually measured already, right? So having the dirt, the soil in this container tells us exactly how much we have here, and it's measured up to 90 milliliters, okay? not a liquid, but it's measured here. Okay. So we can say that we're going to use about half of this soil in each container. So I'm going to pour half of this container of soil in there. Okay. Roughly half. Remeasure. I need a little bit more. You know what I'm thinking would be useful right now is having like a spoon or something to help scoop this dirt out. But that's okay here. Awesome. So I'm just using the scale here to roughly tell how much dirt I have in there. All right, roughly half of the container. Measurement won't be perfect there. The dirt might be stopped down more in one than the other, but rough numbers, yes? Agree? Awesome. So half the container here, then the other half of the container I'll pour in the next one. So they have roughly equal amounts of dirt in there. Again, pack it down a little bit. All right. Again, maybe the measurement's off a little. This one looks like it doesn't have as much dirt. The dirt may have got compacted down there a little bit. All right. So now you can see already we have in our containers here, we have a drainage layer that we created and a layer of topsoil for the seeds to grow in. So let me just prep the next two containers. Put those extra beads to the side. Again, same thing. We can move the dirt into one of the containers here. Awesome. Fourth container of dirt will be full. Great. Looks like it has a little too much dirt, just like last time. Put a little bit more in there. Roughly the same environment now. Yes, agree? Awesome. I heard all of you agree with me. Great. Now we have to start thinking about the setup for our experiment, what we're going to do, right? So we have 4 containers here. One of these containers, we can take seeds, carefully open them. We could also count how many seeds we're going to put in each container. All right, I want to open this bag without making a mess everywhere. Uh-oh, I made a mess everywhere. Awesome. All right, put the seeds in there so I don't lose them. We can count out how many seeds we want to put in each container. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I decided to put 10 seeds. Drop them in the container there. Okay, 10 seeds in the container there. Cover them with dirt. All right. Next container, 10 more seeds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Awesome. 10 seeds in the second container. Next container, 1, 2, 3. That seed looks broken, so let's not take it. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 more in the next container. All right. And it looks like we're going to have a lot more seeds left over, which is okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 seeds in that container. We have a lot of seeds left over, so I'm just going to change it a little bit. I'll put a couple more in each container. Again, that'll just give us more samples to grow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, is this the only way that I could have determined how many seeds I want to put in the container? No. When your students are doing this lab, or your kids at home are doing this lab, you could allow them to choose the method of determining the control groups, right? So I put 20 in there now. They could have counted as many as they wanted out, as long as they have an equal number in each. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They could have also chosen to weigh them, maybe, right? Just as long as they have some sort of consistency that they do in their measurement. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So I have 20 in 3 of the containers now. Just measure 10 more out. Again, we have lots of seeds here. That's okay. 3, 4, 5, 6, 7, 8, 9, 10. Okay. Cool. All done there. Put all of these seeds left to the side. They were so generous with the amount of seeds that they gave us, which is cool. You could do this lab over and over again. Or maybe if you're not happy with the results, right? Do that again. It's also great to have a lot of seeds because maybe you do want to do this experiment multiple times to remove any ambiguity in the growth or the results, right? So you could do that. Maybe you have enough containers here. You could set up a couple more samples if you wanted as well. Okay. All right. So now you have to figure out what you're going to do, what kind of treatment you're going to give to these environments to leave them growing. I know one of the treatments that we're going to give to the group, to these groups, is one is not going to have any water or any sunlight, right? So I have this container here, the seeds are in there. This one is not going to have any water, so I didn't put any water in there. And it's going to have no sunlight. So that's where these little tubes come in. Excuse me. You can, after you have this, cover the tube, right? Cover the container with the tube. Put the top on top of the tube. And you've now just sealed out that container from any light or ambient light that would be in there. It will be dark for the rest of the experiment time, right? Okay, so I am going to take it off really quickly. Just showed you what I was doing because I want to label my containers as well. So I'm going to grab a marker or a pen, the little sticky tapes that they have, and you can write on here before you put it on the container or after. It works both ways. All right, I just wanted to make sure which side was to write on. So you can cover this container with the label, and you could label it any kind of indicators you want. You could use pictures, like maybe a sun and an X through it, and water droplet with X through it. I'm just going to write the word no light and then no H2O, right? And you can see on there, I labeled no light, no H2O. So that's my first one. Okay, covered. The next one, we're going to say that we need to add water to it. I'll put the label on. Cover it up here. Okay. Make sure those seeds are there. Now we're going to say no light. No light. And then, since this one has no light, the other thing that we could talk about is water. We do want to add water. So I'm going to write H2O, no light, and then yes. Let's make sure we're specific here. So I'll say yes, H2O. Okay. You could write down the quantity of H2O that you put in there. Could you give me some water real quick, please? Maybe in this container. Let's fill it up to the top. Thank you. Asking my assistant to give me some water as I forgot water. So this one will have no light, but it will have water added to it. So when we have that covered up, again, there will be no light in it, but there will be water. So maybe it will grow that one. All right, so I have a container of water here, but I want to measure how much water I'm going to put in there. So I'm going to use the other container that I have here. I will use the clean one. Remember, there are two with soil and a clean one. The clean one we're going to use to measure out the water, okay? So that way there's no other contaminants in there. Now, we have the measuring on the side there. You shouldn't measure anytime you're in the air like this. So I am going to eventually put it on the ground so I could get a more, on the table, so I could get a more concise measurement there. And put it over there so I can read. It looks like we are at 15 milliliters, a little over. I'm going to go up to 30 milliliters. Again, you can pick how much water you want to put in there. The students could do that as long as they keep track of their measurement. Okay? So again, we have 30 milliliters of water in there. I am going to pour that into my soil. And now that's where the drainage layer comes in to make sure that the soil doesn't stay too wet. A lot of that water is going to go right through the soil into our drainage layer, and then it can be turned into rain and evaporate as a terrarium. That's why it's called the self-water terrarium. You don't have to add any more water to the system. Okay? Cover it up. And again, just because I don't have a data table or anything here, I am going to also mark on my label here 30 milliliters of water, right? So yeah, no light, yes, H2O, 30 milliliters. All right, good to go with that. Lid is covered. Label is on. Awesome. So now you see we have two containers. We have our two containers done. One container with the treatment of no light, no water. Second one with the treatment of no light, water. So the next container, we're going to give both treatments to. We're going to give it water, and we are going to give it light. Okay. Awesome. So again, I'm going to measure out. We're giving it water and light. So I'm going to measure out 30 milliliters again. 30, so let's put some water back. Perfect, 30 milliliters. 30 milliliters of water. Again, it's a control. I control the same amount of water that I put in the first container that had treatment of water as the second. Okay. Cover it up, seal it, put a label on it. My next label. I'm sorry, but these labels are sometimes hard to get off here. Alright, try again. Got it. Let's put it on here. So I've labeled 3 sample cups now. This one, if you all remember, is going to be yes light. Again, this is just the way I'm labeling it for you right now. You can choose any pattern of labeling that helps you remember. Maybe you just want to do light and water in a check box and write a check next to it. And then yes, H2O. Okay. And again, I put 30 milliliters of water in there. So yes light, yes H2O, 30 milliliters. Okay. Do I cover this one up? No, don't want to cover that one up because I want light to hit it, sunlight to hit it. And then my last container that I have here is going to be sealed completely. I didn't add water to it because I want a container that has a treatment of no water and just light. And then we can see which environment is better for our grass seeds to grow in. Whether they grow better with light and water, only light, or only water, or neither light nor water. Take that up. Label on. What did this one have? I forgot. All right, this one had yes light, no H2. Oh. All right. So we have our experiment completely set up here now, right? Your students may choose to do other containers. They might do a container like I did here, you know, and this is their choice in their experiment. You could let them do things like this, but maybe they want to try a container also where they do no soil, water and light, right? And then maybe they want to do one that has no soil, no light, water only, right? They can choose how they want to set up their experiment, what parameters they're going to check, and you could talk about the pros and cons in class of having certain results over the other. That's all going to be determined on what they want to test right now, okay? Right now, I am just testing the effects of light and water on the growth of grass seeds. They could check soil as well if they wanted to. So you have these additional cups where you could put grass seeds in there. Maybe you count out 20 grass seeds. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's one off there with my pinch. One off. Not bad. So they could put 20 seeds in there. Maybe they want to put 30 milliliters of water. Oh, I should measure that out in a separate container before dumping in there, huh? Okay, let's grass seeds out of there. All right. I'm just making sure there's no other grass seeds in here. I think they're all out. I left a little bit of green in here, but there's no actual seeds. All right. So 30 milliliters of water coming right up. Put it on the ground, measure it, flat surface. All right, that's about 30 milliliters of water. So maybe they want to do this as well. They make a fourth container there where they put some grass seeds and water in light. And maybe they do another one and they put it in the dark there. Maybe that's what they want to do. I don't want to do that for my experiment right now, so I'm not going to do that. But again, maybe that's something that they could test out. And you should be okay with that. You should let them test it out and make their own science experiment. As long as they can bring up the correct scientific questions, so they're testing for the right thing, as long as they're making their hypothesis with it, they're making their variables and controls, what features they're changing. They're only changing one variable at a time, controlling that experiment well. Okay. Awesome. So we have our lab all set up here, labels on it. Again, this is something you're going to set up and you're going to do it over time. After this is done, you're going to put it in a windowsill and you're going to let it sit there for some time. You get to choose, again, your students get to choose how often they're going to come back and observe it, whether they're going to observe it once a day maybe if you're in a classroom environment, right? Maybe they check it at 12 p.m. right before lunch every single day. Maybe they check it twice a day, beginning and end if you're in an elementary school setting. Maybe they check it every other day. Maybe they check it once a week. Choice is yours. They set the time frame as long as they are consistent with the measurement of their time frame. Again, keep all the results, all the data, keep track of that. Now, I've done this experiment with students before, and I'm sure a lot of teachers have. It's not something that we've invented, right? This experiment has been done countless of times. What I personally like about the way that we have the kit set up is oftentimes when this experiment is done in a classroom setting, there's no way of actually covering the groups that have no light, right? So some teachers may opt to collect all the kids' sample cups that receive no light. They put them in a box and they store them in a container, you know, like in a closet or something, or a cabinet or a drawer. And then they just leave the containers with light out on the windowsill. But when they've done that, they have now created a place where they're not in the same general vicinity, right? So temperature might come into play, and they don't think about that a lot of times, right? You've changed the environment where it is, and that's changing a variable in the experiment. So by having it set up like this, students are able to put all 4 containers in the same exact setting. They've received all the treatment that they received, but they're all in the same exact environment for the entire experiment. So you removed one of the variables from the experiment, which will give more validity overall to your test, right? And so I find that very important. So the only time you're going to remove these are when you're doing observations. And you would set all 4 into a windowsill outside, maybe on the patio, anywhere where they can receive light. I just thought of this as well. This might be useful. I like the labels on the containers, but you cannot see the container labels when you have the tube on top of them. So it may be helpful to write on the outside here as well what treatment each one of these tubes got, so you don't have to keep lifting it up and looking at it. However, I do recommend keeping the label on the container as well, because sometimes the kids might mix them up. Notice how I just slapped the entire label on there, but these labels were plenty big enough where they could have cut them and made 2 additional labels from each one. So instead of 4, they would have had 8, and that means they could have labeled, if they chose to do this experiment with the seeds and water and light and no soil, they could have done that experiment as well and added those containers to their experiment lid here. After you do the experiment, you all know, you make your observations, you conclude, come up with a conclusion, which one will help grass grow better, whatever the question is. We will see. I can't see, I told you they're not magically gonna pop out of thin air today, but we were gonna set up the initial experiment and show you the setup that you have with the kit here. I really like the kit. It's comprehensive. You could do it at home. You could do it in a classroom setting. Perfect during these times where we're learning from home and distant learning. You're giving your students all of the materials that they would need to complete this kit. And they need water, right? You add water and sunlight. But we all have that available to us, I think. And there you go. The experiment is ready to go. Out of curiosity, I'm going to actually do this experiment and see. I believe I know the results already, hopefully, but it is always good to test and retest your thinking, right? That's what scientists do. Maybe you'll get different results. Who knows? Maybe you'll be surprised by results. I'm thinking that maybe some of the soil might have some moisture, so we may have some growth in places that I wasn't expecting. But I will do this lab. I will put it up there. I may record another video showing you all the results after a couple days. I'm not going to go through the entire experiment data table, personally me, but I will see the growth and monitor it from a couple days to a couple days. Well, again, this was a short video, easy setup to do. This is good for kids of all ages, from doing this in elementary school. That's what I wanted to say. I always forget this. This is an elementary school project kit, right? However, even me as a physics teacher, when I was teaching, I would use a setup like this in the beginning of the year to just talk about the scientific method with my students, because they had biology in the years past and may have done something similar. So I think this would be a cool addition to a physical science class, because I could just study scientific method with my students on something that they should already have knowledge of in the high school setting. So if you are a physical science teacher, don't look at this kit and be like, oh, it's of no use. Scientific method is important, and it's important in all sciences. Easy setup, easy experiment to do to get kids started at the beginning of the year. So don't be afraid to try this, whether you're preschool, elementary, middle school, or high school. Heck, even college kids and teacher education programs could probably do this experiment when they're teaching scientific method. Well, thank you for joining us today. We will be back here later in the week with another project from Kate. You all have a wonderful day, and we'll see you soon. Bye.